Welcome to EDUCARE. In this video, the three-phase transformer classification, groups, clock diagram and connection will be described. Based on the interconnection between the transformer winding, the three-phase transformer can be classified into four groups. Number 1, delta transformer. Number 2, star transformer. Number 3, delta star transformer, and number 4, star delta transformer. And based on the phase displacement between primary and secondary line voltage, be careful here, primary and secondary line voltage transformer can be grouped into four groups. Number 1, 0 degree group. Number 2, 180 degree group. Number 3, plus 30 degree group or 30 degree leading. Number 4, minus 30 degree group or 30 degree lagging. Now clock diagram. In clock diagram, HB line voltage, be careful, line voltage is taken as a reference, and we observe by see the LB line voltage, whether LB line voltage in phase of HB line voltage or anti-phase of HB line voltage or leading or lagging, we will observe it. Suppose in this clock diagram, we will explain 0 degree group. This the 0 degree group. Here, suppose this is a clock. This is 12 o'clock. This is 3 o'clock, 6 o'clock. This is 9 o'clock. In the clock diagram, we always put HB line voltage at a reference, that is at 12 o'clock. This is the HB line voltage at 12 o'clock. Now, for 0 degree group, there will be no phase difference between HB line voltage and LB line voltage. That means the phase displacement between HB line voltage and LB line voltage will be 0 degree. That means the LB line voltage will be at 12 o'clock also. This is 0 degree group. That means if the HB line voltage and LB line voltage at the same phase, then it is called 0 degree group. Again, this is 12 o'clock, 3, 6, 9 o'clock. This is 180 degree group. Again, for here HB line voltage is the reference and it is along the direction of 12 o'clock. In 180 degree group, the LB line voltage will be anti-phase of HB line voltage. That means if it is 12 o'clock, then HB line voltage is 12 o'clock, then LB line voltage will be at 6 o'clock, opposite direction, the opposite direction. Here, the plus 30 degree group, that is complete also, plus 30 degree group. It is 12 o'clock, this 3, 6 and this is 9 o'clock. Again here The HB line voltage is the reference. It is directed along 12 o'clock. And for plus 30 degree groove, the LV line voltage is leading HB line voltage by 30 degree. That means for it's 12 o'clock, this is 1, 2, 3, 4, 5, 6, 7. 6, 7, 8, 9, 10, 11. There are this along this is 360 degree, this is 360 degree, and it's divided by 12, that is equal to 30 degree. That means for 12 o'clock to 1 o'clock it is 30 degree, from 1 o'clock to 2 o'clock 30 degree. Similarly, from 11 o'clock to 12 o'clock the angle is 30 degree. Here plus 30 degree means LV line voltage will be lead. This will be the LV line voltage. LV line voltage will lead HB line voltage by 30 degree. This angle is 30 degree. That means if the HB line voltage is at 12 o'clock, then LV line voltage will be at 11 o'clock, and it is called plus 30 degree group or 30 degree leading. Now in minus 30 degree group or 30 degree lagging, 30 degree lagging, it is 12 o'clock, 3, 6 and 9. HB line voltage in the direction of 12 o'clock, and the LB line voltage, this is 1, at the 1 o'clock this angle will be the 30 degree. Here LB line voltage lags HB line voltage by 30 degree, then it is called minus 30 degree group or 30 degree lagging. Now I will explain three-phase transformer connection and phasor diagram. In Indian standard, the HV winding is represented by capital letter. Suppose for three phase, capital A, B and C, and LV winding is represented by a small letter, and for three phase this will be a small a, small b and a small c. Suppose for HB winding has more number of turns like this, and suppose this is a phase A. For LB winding less number of turns and represented by a small a. Similarly, for B phase, the B phase, and for LV B phase like this, and for C phase like this, capital C, small c. Now every winding has a starting point and end point. This is the starting point, start point, this is the end point. Similarly for LV, there is a starting point, end point, and starting point is A1, capital A1 for HB, and A2 for HB. Here a small a1, a small a2. For B phase, B1, B2, a small b1, b2, capital C1, C2, a small c1, c2. And the end of every winding is represented by dot. This is starting, end, starting, end. Therefore, it is represented by a dot. It is represented by a dot. End of winding is represented by a dot. Similarly, end of pointing is represented by dot, represented by dot, end of pointing represented by dot, and represented by dot. For drawing the phasor diagram, one point must be clear. The LV phase voltage must be parallel with HB phase voltage. Point to be noted, HB phase voltage, not the line voltage, will be parallel of HB phase voltage, not the line voltage, for drawing of phasor diagram. Now, the three-phase transformer connections can be classified as number 1, DD12 or DD0. What do you mean by DD12 or DD0? D capital letter high voltage, D small letter low voltage, and 12 means 0 degree group. 12 means 0 degree group. It is 12. The HB along 12, LB along also 12. Therefore, DD12 or this is 0 degree phase difference, DD0, same. Number 2, YY12 or YY0. That means HB is connected in star connected and LB is also, this is HB, this is LB. Is connected also in star connection and their phase displacement is 0 degree. That means it is 12 o'clock, LB 12 o'clock, HBO 12 o'clock. Number 3, DD6. DD6 means HB is delta connected, LV delta connected and 180 degree phase group. That means phase displacement in 180 degree. Number 4, DY6. Sorry, DY11, not DY6, DY11. This is HB delta connected, LV star connected and LV at 11 o'clock. That means that is 11 o'clock. This clock diagram. This is plus 30 degree group. Plus 30 degree group. Next, DY1. HB delta connected, LV star connected and it is minus 30 degree group. That means LV at 1 o'clock. This clock diagram is minus 30 degree group. This is 0 degree group. This is again 0 degree group. This is 180 degree group. Next group is 1, 2, 3, 4, 5, 6. Y6. HB star connected, LV star connected and 180 degree phase displacement. 7. YD 11. HB star connected, LB delta connected, and it is LV at 11 o'clock, that means plus 30 degree group. Last one is the YD1. HB star connected, LB delta connected, and the LV line voltage at of 1 o'clock, that means minus 30 degree group. Start DD 12 or DD 0. For the connection diagram, first you draw D. D means first you draw high voltage. This is the high voltage A phase starting A1 and A2. End is dotted line. Then you draw B phase starting B1, B2 and end is dotted, and C phase starting C1, C2, end is represented by a dot. This is HB winding. For LV, this is the A phase, starting is A1, end is A2. End is represented by a dot. B phase, starting is B1, end is B2. End is represented by a dot. This is the C1, C2, C phase, end is represented by a dot. For D, D means delta. High voltage is connected, it will be delta. D, small d, that means low voltage. This is the low voltage will also connected in delta. For delta connection, A1 will be connected to B2. Here B1 will be connected to C2, and this A1 will be connected to C1. Similarly here, A1 will be connected to B2, B1 connected to C2, and C1 will be connected to A2. Here the input and output. The input may be dotted or undotted, and output also may be taken from dotted or undotted. Here DD12 or DD0, the input is given from the dotted terminal and output also taken from dotted terminal. Now I want to draw the phasor diagram. For drawing the phasor diagram, I arbitrarily draw any phase. First I will draw the HB. I will draw the HB. This is the A1, A2. A1, A2, and this is the A phase. Here A2 is connected to C1, therefore it is the C1, and therefore we write Right on the C phase, C1, C2. This is the C phase. This C2 is connected to B1. B1. Then I draw the B1, B2. This is your B1, B2, and B2 connected to A1. B2 connected to A1. This is your B phase. This is A phase. This is B phase. This is your C phase. To draw the LV phasor diagram, as I mentioned earlier, the LV phase voltage will be exactly parallel to HB phase voltage. That means this is the capital A1 B1, sorry, A1 A2 HB phase voltage. The LB phase voltage is a small A1 A2. That means the LB phase voltage A1 A2 will be exactly parallel. This is exactly parallel of A1 A2. This is the A phase. Again here A2 is connected to C1. Here C1 C2 HB phase voltage and LB phase voltage will be exactly parallel like this. Exactly parallel C voltage. Here C2 is connected to B1. Connected to B1. Again B1 B2 will be exactly parallel. B1 B2 will be exactly parallel, and B2 is connected to A1. B2 is connected to A1. This is your B phase. For finding out the groups, I'll see the line voltage. For drawing the phasor diagram, point to be clear, for drawing the phasor diagram, the LB phase voltage and HB phase voltage will be parallel. For finding out the groups, we'll see the line voltage. How it becomes DD0? I take any line voltage, suppose C2 B2, the V of C2 B2, and the corresponding LB line voltage will be the V of small C2 B2. Here C2 B2, this is the C2, this is the B2. This is your HB line voltage C2 B2. And what is the LV line voltage? V of C2 B2, small. This is C2 B2, and this is again in this direction small C2 small B2. V of C2 B2. Therefore, if we compare with the help of clock diagram, suppose it is 12 o'clock, then it will be 3 o'clock, it will be 6 o'clock, it will be 9 o'clock. This is the HB line voltage, V of C2 B2 in this direction. The LV line voltage will be the same direction. There is no phase displacement, 0 degree phase difference. Therefore, it is 0 degree group or 12 o'clock. Therefore, it is HB is connected in delta, LB connected in delta, and 0 degree phase difference. Therefore, it is DD0.